Okay, more problems from section 5.1. I've got the sketch here. I didn't get a chance to draw it, so I just wanted to take a look at it. Basically, we're going to estimate the volume of a hemisphere. That's half of a sphere, and this is kind of showing a side cut of it. And we're going to partition the hemisphere, and this is actually the radius of the hemisphere, which is 4. We're going to partition this 0, 4 interval into 8 subintervals, so each of those will be a half a unit. And what we want to do is think of these as coming all the way around, so you can't see this is a cut, but each of these would be just little cylindrical slices of that sphere, similar to some of the other problems we saw earlier, I think, in the examples. I think we might have an example over there somewhere, I think. I had some pictures of one, but I guess not. Okay. Thought for sure there was like a cut of that. Yeah, over here, this one here. So it's kind of like this, but we're just going to be looking at the half, so we're going to have all these cylinders coming out. Okay, so, but again, we're just going to be dealing with half of the sphere. Okay, so we'll go back and look at this. So you just have to imagine that. So these are all cylinders, and we're going to have, each one of them will have, and this will be, if you tilt it over the side, each of these will be the height of the cylinder, and that's going to be the radius of the cylinder, given by this equation. All right, so that's actually going to be the radius of each of these cylinders. And this is actually the radius of my whole sphere, but we're looking at all these cylinders separately. So I have a cylinder here, and the radius would be given by this height here, y, depending on where I'm at. That's actually going to be the radius of the cylinder, and this would be actually the height as we look at it like this. So you can turn it over sideways if you want. And you can think of these as a side cut of these cylinders. And there's the height, which is 1/2, and then the radius is given by whatever this value is, this equation. Okay? So that's kind of the idea of what we're doing. So wrote it up over here so you can take a look at it. So for a cylinder, the volume of each cylinder would be base area times height, which would be pi r squared times height. Okay? And I'm on this interval, so n equals 8 means that the height for each cylinder will be 1/2. And so the volume equals pi h r squared, and the r, the radius, will be given by the curve. Y equals the square root of 16 minus x squared. So if we're going to use LRAM, we're going to start on the left. That's what they wanted you to do. Use this as the left approximation, just the left. Save us a little bit of work. So I'm going to, my left endpoint will be 0, so my height will always be the same. That will always be 1/2, and I'll put that in down here. Pi is always going to be the same, so I'm going to have 16 minus, and then my r will be given from by the left endpoint, and you can see that that's going to be 16 minus 0, which would be the square root of 16. That kind of makes sense. The square root of 16 is 4. So if you look over here, this actually would be 4, so that does make sense. Okay? And I'm just going to use my left endpoint. 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5. Those are the left endpoints. The right endpoint is 4, and I'm not using that because I'm using the left approximation. Okay? So 16 minus 0, the square root of 16 minus 0 squared, because it's pi h squared. So we're going to square all these, so that's nice. So 1/2, 16 minus 1 squared, 16 minus 3 half squared, 16 minus 2 squared, 16 minus 5 half squared, 16 minus 3 squared, 16 minus 7 half squared. But when I square all these, that makes it nice. It's just 16 plus 16 minus and 1/2 squared is 1/4. 16 minus 1 squared is 1. 16 minus 3 half squared is 9/4. Square root of 16, so that's good. That will just cancel out the square root sign. 16 minus 4. 16 minus 2 squared is 16 minus 4. 16 minus 5 half squared is 16 minus 25 over 4. And 16 minus 3 squared is 16 minus 9. And then plus, finally, 16 minus 7 half squared is 16 minus 49/4. I had 1, 2, 3, 4, 5, 6, 7, 8 16s. And I had -1, -4, and -9 is -14. And if I added up my fractions, 1/4 and 9/4 is 10/4, 35/4, and 49 makes the minus 84/4. I did all this numerically. So far, no calculator. Pi times 1/2, that was my height of all the different cylinders. And that's 8 times 16 is 128 minus 14 minus 21, ended up being 93. So it was 93 pi over 2. Then I used my calculator, I calculated that, and that was actually the sum of those 8 cylinders. That was the approximate volume. So that was your approximate volume. Then they wanted to find the percent error, so you could take the actual volume. Now remember, the volume for a sphere is 4/3 pi r cubed, and we took half of that for the volume of a hemisphere? Hemisphere, pardon me. So I just put 2/3, so 1/2, 4/3 is 2/3, so 2/3 pi, and then the radius of my sphere was 4. So 4 cubed, it ended up being 134.041. The percent error will actually be the error over the actual volume. That's why they want you to find the percent error of the volume. So if you did put this in your calculator, the absolute value of V minus S sub 8, take the absolute value of that and divide that by V, you end up with about 9%. Rounds off to be 9%. Okay? So I hope that one helps.